Okay, testing audio. Can you guys hear me? Alright, cool. So the problem links, I sent them out in an email already. So just like check the old emails, I guess. So if I make the stream better than 480, it'll start lagging a lot. And that'll suck. Yeah, problem start at 8:30. Okay, can you guys see the code? Sure. Can zoom in. Oh. Okay, is this size better? Okay, cool. So we're not starting the problem discussions until 8:30, but if you have any questions about like coding related stuff, how to debug, how to get better or stuff like that, you can ask me that now. So the structure of the course is, alright, I'm gonna go by these one by one. So the structure, okay, so the structure of the course is based on the feedback, I'm gonna try to lead people towards the answers instead of just presenting the answers. But if it's a really complicated problem, then I may just present the answers. In terms of how to get red, I don't know. I'm not yet red, but I don't know. How do you approach DP problems where it asks you to count the number of solutions? Well, that's, you just make your DP thing equal to the number, and we'll go over that when we do Python indentation. But yeah, in general, you would make DP something equals to the number of solutions. How do you study for USICO Gold? Okay, I have a Quora answer on that already. Basically, the topics you need are like DP, Dijkstra's minimum spanning tree, set, multiset, two pointers, binary search. Is there a slight tick? Will the videos be available after live streaming? So currently I'm thinking to not make them available. Because I don't want people to procrastinate in watching, because that never leads to good things. Okay, do I write brute force code before optimized code? Generally speaking, I don't, because so if I can't come up with the optimized code, I'll write the brute force code. But if I write the brute force code and then the optimized code, then I just sort of wasted time by writing the brute force code. How did I start CP? What do you mean by that specifically? Like, why did I start CP? Or like, how did I start coding? I'm not quite sure. Okay. If you're still asking for the problem links, I guess I'll just send them. Okay, those are all the problem links. Okay, how did I get into it? Basically in middle school I did math competitions, and then I didn't like math competitions, but I liked coding, but I'd never done like competitions or stuff. I just done like basic loops and stuff. So I figured I'd do coding competitions because I don't want math competitions. Okay, is upsolving greater than code forces rounds? Definitely. Any problem you solve during code forces rounds, like let's just say you were to practice it's basically a waste of your time, because during a contest, like during the code forces round, you already solved it, so you didn't really learn anything. But when you upsolve, then you're solving problems that you would not normally solve during a round, so you're learning new things. Do I have any advice from converting top-down DP approaches to bottom-up? For bottom-up, you just use loops. For top-down, you use recursion. So to go from bottom-up, if you know like some DP states, the question is how do you get to the next state knowing all the previous states? And that's how you do bottom up, basically. I'm not sure if that's clear enough. If that's not, please tell me. Okay, how to prove a DP solution is right. DP solutions are generally right, unless they're not, but I guess that's not helpful. Oh. Generally, to prove a DP solution is right, you just that's a tricky question. Basically, if it sounds right, it probably is right. Like, I've never had issues with DP solutions being wrong in general. Maybe like once or twice. Sorry, I can't really help that much. Okay, how is this session going to be conducted? I've already answered that, but basically, we'll go over the problems, and I'll try to lead you guys to raise the solutions instead of just presenting them myself. Math? Oh, math is hard. That is true. I tried solving problems but was stuck for a day and was not able to solve them. How do I approach them? Look at the editorial. 17. How to implement 26-degree sec tree. It's a very simple answer. You just don't implement it. Quality is too low. So the problem is if I increase the quality, then it'll lag a bit more. Currently, here, let me open this up to see what the lag is currently. Currently the lag is like 3 seconds, but it started at 0 seconds, so I don't want the lag to get too high. Plus, if you can see the text, then it's probably fine. How many questions will be given to practice throughout the course? I'm thinking 3 to 4 problems a week. How to approach math problems. My trick for math problems is to just skip the problems. Can every recursive DP be converted into iterative? Generally speaking, yes, because recursive is top down and iterative is bottom up. What's the best way to find out transitions among states in DP problems? So what I do is I think, okay, if I know the first I minus 1 solutions, then I figure from the first I minus 1 solutions, how do I get to the I solution? Like if I know the first I minus 1 states, how do I get to figure out the I state in terms of just logically? And then I formulate it into a formula. Find top down more intuitive. So if you do top down with memoization, it should give you AC in general. Yeah. I can solve using top down, but I get stuck using bottom up. Okay, so today we're just going to do all bottom up solutions, so that should be fine. What is the future course structure? So I've answered this twice, but basically we're going to present a problem, and I'm going to try to give as little of the solution as I possibly can, and like lead you guys into the solution, because during a contest you would have to lead yourself toward the solution. Low quality. Yeah, I'm aware. Do you listen to twice? Nope. How to figure out number of states? Wait, do you mean like as in the max number of states you can have, or given a DP solution the number of states you currently have? Any nice way to convert divide and conquer DP to iterative? I think you mean from top down to bottom up, and we will go over all of that today. I think in terms of bottom up, I used to do top down, but now I do bottom up. Oh, you mean future course structure? Future course structure will probably be the same to this one if it goes well. I'm gonna send out like a survey when I send out next week's problems to see like what went well, what didn't go well, and fix things from that. Generally, the runtime should be the same. The runtime from top down should be slightly faster because you're not filling up all the states. But then you have the issue of like stacks problems. I think that adds a bit to the memory, but that's fine. How much time to devote to a problem before looking at editorial? Okay, so I don't think of this as like how much like I spent 30 minutes out through the editorial. I like to think of this as for the last 15 minutes I've had no new ideas. So I'll look at the editorial. But if you keep coming up with new ideas, doesn't matter how much time it takes you, just don't look at the editorial until you've gone like 15 minutes without looking at the editorial. Number of states in a DP problem. Okay, I'm just going to answer both questions because I don't know what this means. The max number of states you can do is about, I'd say like 4, maybe 10 million. Given your current DP state, like, say I have DP n, n, the number of states equals n times n times n. Is there an easy way to decide what the states of a DP problem are? So I want to try to explain how to come up with that today, and not just that's why I want to not just explain the solution. I want to explain how to come up with what the states are. Generally, you say, okay, if I'm at the ith location, what information do I need about the past I minus 1 locations to come up with the ith location? So whatever information I need, that is what the state is. Oh yeah, and let's just say you need like 3 pieces of information to get the answer to the ith location, but you need like 4 pieces of information to get all 3 pieces for the ith location, if that makes sense. Then you need to store all 4 of those, if that makes sense. I'm sorry if it doesn't. Or if you get bored of the problem. If you get bored of the problem, just read the editorial. If it's interesting, do it, otherwise move on. Is it possible to use convex hull in top-down approaches? I don't think so, no. That would be another advantage of using bottom up. Please provide the recaps of the videos for future reference. Maybe after the course is over. Maybe after the course is over I will. Maybe. How to recognize if a problem is DP and how to approach. Okay. To recognize if a problem is DP, then it generally means if you're trying to minimize something or maximize something or count the number of ways, it's probably DP. Another option is if from the first I minus 1 locations, you can get the answer of the ith location, that's also DP. Because, like, if everything that you did for the first I minus 1 doesn't matter, and you only care about specific pieces of information for the I minus 1 states, then it's probably DP. Okay, I suspect this course is targeted to so you should know how to code. The target range is 1000 to 1700. This week's problems are like 1100, 1500, I think, and 1800. See, 1800, 1600, and 1100. So, oh, so yeah. What topics will be covered in the course? Okay, currently the lesson plan I've designed, we'll do like 3 weeks of DP, some graphs, data structures, uh, miscellaneous topics like binary search, divide and conquer, stuff like that. I forget exactly, but yeah. How do I qualify for USICO camp? Generally, if you can solve platinum problems, you'll qualify for USICO camp. But also, partial credit matters a lot more than is like emphasized, because let's just say you solve one problem fully, you get 333, right? Now, if you solve two problems 50% and you get a 0 on the third problem, that's the same thing as you still get 333. And then if you solve like two problems 30% and one problem 1/3, even though you're not smart enough to solve the first problem fully, you'll still get a higher score, about like between 400 and 500, and that's enough to get into camp. And also, in general, what did I say? Right, in general, if you're trying to get into the camp for first time as a Guernsey, which is the lower level in camp, which means that you've never been to camp before and you're not a senior. Last year, some people solved 0 problems and got into camp, or I think it might have been 1 problem, and got into camp as a Guernsey. And the year before that, I only solved 1 problem and I got into camp as a Guernsey. So I think last year, 1 or 2 people might have solved 0, but don't quote me on that. But yeah, so partial credit is key for getting into USICO camp. We will see things like Convex Optimization and DP with Bitmask. No, that's in course 3. So the thing about this course is I've realized that a lot of times, once you see the solution, it's very easy to understand, right? You see DP solution and you're like, oh yeah, that's so simple. How did I not get that? So that's the main thing that you need to learn to like go from to get up to like say 1900 or 2000. It's basically it's basically how to think in terms of like, if you can read the editorial and you understand it, then there's no reason that you should have not gotten it during the contest. So I'm going to be talking about like how to get those during the contest. And convex optimizations in DP with Bitmask are very rare. And also, there's no point in learning new topics if you cannot solve problems with the topics that you already know. So no, I will not be covering convex optimization in DP with Bitmask. Okay, what is this park bomb thing? This is like not the first time I've seen this message. Can you stop saying that, please? Oh, where this will be 10 weeks. Yeah, this is right. If it's marked as DP, there is a DP solution. There might be other solutions too, but there is a DP solution. What is the difference between bottom U? I don't know what that means. How do you find good problems for a specific topic? Codeforces sort by topic is definitely good. Also sort it by difficulty. So like if your rating is say 1250, solve problems that are like 1300 or 1200. Don't try to go too hard, don't go too easy. It's a waste of camp. Waste of time, sorry. I'm a junior, but I have never been to camp, and I am in play and I do well. Good for you. Okay, well, I'm too rude, but like, I don't know if that's a question or not. Don't know what this is. Can I suggest some basic DP problems? So again, to find basic DP problems, just go to Codeforces, and then go to the problem set, and then click DP, and then sort by difficulty, and then click it again so it's easiest to hardest, and you could just start solving like downwards. And those are easy problems at first. If it's marked as DP, there again is a DP solution. Here there might also be a greedy solution because it's marked as DP and greedy, but there is a DP solution. This is true. Yes, Guernsey is skippable. Last year Spencer Compton skipped being a Guernsey and he went straight to being a Holstein. I mean, how old is well, right? Like, I don't know. Um, okay, if Park Bomb, I mean, I don't think they're here and they're definitely not responding, so yeah, I don't know. What is this problem? Oh. I mean, you can look at the editorial to figure out how to solve it. I'm not gonna read the problem just right now. 700 plus. Oh, hey, look, is this Park Bomb? Okay. How to become good at Code Forces contest? Uh, I don't know. Just, I guess, okay. I guess being able to solve problems, like hard problems, is more important than being able to solve fast problems. So, yeah. Um, basically, the idea is, okay, here's what I'd recommend. Go to problem set, right? And let's just say that your rating is like, say, 1500. Just type in 1500, 1500, and just apply. And then just start solving problems from like, just start here with the first problem and then keep solving. And basically, if you can go like 3 or 4 problems without looking at the editorial, then you're good. And then go to 1600 and repeat the same process. And you just keep repeating over and over and over again. And eventually, you'll become good at problems. What's your take on the idea that past experience with problems matters a lot in contest performances? Um, I think, I don't know. I think, okay, problem writers have solved a lot of problems in past contests. So I suppose it makes sense that if you solve a lot of past problems, you'll do well. You definitely need to solve a lot of problems to practice and get better, because if you don't practice and someone else practices, they'll of course beat you. I don't know. If you have like a more specific, I really don't know how to answer that. I do agree that the more you practice, the better you'll do. But you have to practice on hard problems, not on easy problems. Like, for example, if you're trying to learn calculus, and you're like, okay, addition is math, calculus is math, so I'm just going to practice a bunch of addition problems, and eventually I'll get good at calculus. That's not going to happen. You have to practice increasingly difficult problems to get good at calculus. What about practicing medium problems to get faster? I personally think that that's a waste of time. If you can solve harder problems, you'll automatically be faster at medium problems. And also, solving medium problems doesn't, like, getting faster at medium problems won't help your score as much as solving one more problem. Like, if you can solve A, B, and C slightly faster, or if you can solve D, solving D is a lot better. Okay, I'm gonna check the lag again. See what the... So it's still at 3 seconds, which is not bad. I agree with this. Sometimes just the problem statement is just, I don't get it, and I mess up in reading the problem statement, and then I solve a completely different problem, and then I get wrong answer, and I'm trying to figure out why, because I thought it was an easy problem. Turns out I read the problem extremely wrong. That sucks. I wouldn't know. I know some Usimo people are into Yusuko. I have not done Usimo. There's some people who go to MOP and Yusuko camp, so. Okay, it's 8:30, so we're gonna start. Basically this means that, like, as of right now, please try to limit your comments to strictly questions about the topic. So, okay, the text with the problem statement doesn't have to be readable as long as the text in the code is readable. This is because the problem statement you can open on your own computer. So, yeah, you've not missed anything in the past 30 minutes. I was just answering random questions. Wait, so Ahmed Hafez, can you see the text that I'm typing in the code editor? Yeah, okay, cool. Okay, so we're gonna start right now with the first problem here. So since we're starting, I'm gonna request that I'm not gonna use Java, I'm gonna use C++. Yes, thank you, Michael. Okay, so no random questions like hi or just random questions. Questions have to be about the problem statement and what I'm talking about, just so that I can actually see this. Okay, I just said no comments like hi. So we have two moderators, Michael and Filippo. We can all see Michael here. Filippo, can you say hi? If you're there. There he is. So basically, they're going to make sure that the conversation is staying on topic. So yeah, again, you can ask questions about the topics. You can also answer questions about the topics. And basically, if you're spamming a lot, they're just going to block you. So just please don't do that. Okay, I'll post the question links one more time. And then we're going to start. So these problems are not caustic problems. Alright, let's start with the first problem. So just to summarize, you have n numbers of... That's a good idea. I don't think I can. No, I don't think I can pin the questions. Okay, basically, you should have all read the question already. Just to summarize, you're given like a number line basically. The frog starts at point 1 and she's trying to reach point n. She can only jump... Okay, description will work. That is a good idea. Do we need a... Okay. They're being... Cool. Are the problems visible in the description now? For those of you who can see the description. Are they visible? Yeah, cool. Okay, thanks. Alright, so you're trying to go from point 1 to point N, and you can only jump from between 2 points if they're within distance d of each other, and if both the points have lily pads on them. Okay, so clearly this is a DP solution, a DP problem, because it's in the topic of DP. So does anyone have any ideas as to what would be a good state? For example, if I know something about what information do I need to know, say, about the first 4 points, such that I can solve it for the fifth point here. But yeah, again, since you're trying to output the minimum number of jumps that the frog needs to reach home, a good idea is that the DP will equal to the minimum number of jumps. Jumps to get to point I. Yeah, that's about right. So it needs to equal to the minimum number of jumps, and it seems like the only thing we need to do is we need to know the index. Try with. So this is a greedy solution. Okay, so let's say that I'll put this on this one. Okay, let's say that I find DP, the index, equals to the minimum number of jumps. Okay, if I know everything up to DP I minus 1, so I know all the DP states from DP 0 to I minus 1. These I know. How can I use these to get to DP I? Okay, please stop. Alright, so if you know everything about check the points in the range behind it. Yeah, that's correct. How many points do you need to check behind? If you already solved this problem, you're also allowed to give ideas too. Yeah, okay, this is pretty much correct. 1 plus the minimum of any cells that are with the max jump distance. So, first of all, if the lily pad equals 0, right? So if it's not a lily pad, if it's a 0, then the minimum number of jumps we need is infinity. Because there's absolutely no way to end up at this location. If it is a 1, then this works. If it is a 1, then that means that we can check the D points behind it. Yeah, exactly. The D points behind it, because these are the locations that this DP state can come from. So for example, if we were in the location here, we can jump forward. We can go 1, 2, 3, 4. If we're checking this location, we have to check the D spots behind it to see if it's possible to reach the spot. So what we can do is we can loop through the previous D spots. Actually, I'll just write the loop where j equals I minus d up to I minus 1. we say dpi equals to the min of whatever it currently is, and dpj plus 1. So from that previous location, we could take one more jump to reach the current location, or we could use what we already had from the previous jump. Okay, any questions so far? Oh, this is a good idea. That's a very good idea. Okay, I will do that. Okay, any questions so far? No? Cool. So, what's the runtime of this so far? The runtime of a DP in general? The runtime of DP in general equals the number of states times transition for each state times, there's something else, I can't remember. Oh, it'll come to me. It'll come to me. Okay. Yeah, n times d is correct, because if you look at the runtime of this, the number of states equals equals n, because dp index, and the index goes from 0 to n, or 0 to n minus 1, I suppose. And the number of transitions for each state is d, because we have to look at the past d things. So for each of them, we just we loop through d items, so it's O of n times d. Okay, we can do this fast. Oh, why is it min d of I? Oh, okay. So basically, what we're doing here is we initialize. I'll put that code in here somewhere. We'll initialize. We'll say dpi equals to infinity, and we're trying to take the minimum of a lot of values. So we take the minimum of what it currently is, which originally it currently is infinity. The minimum infinity and the other value. And now dpi is updated with the value of 1 dpj plus 1. And we keep repeating this for all the dpjs. Okay, so it turns out that we can in fact do this faster. Without using greedy solution. So the idea is that, and it sort of is 2 pointers. 2 pointers will work. There's another solution here. Yeah, the video quality is a little bad, but as long as you can read the text, we're good. As long as you can read this, we're also good. Okay, so another thing to consider is, let's just say that, so you said that DP, okay, so we said this, right? This is pseudocode. Okay, so let's just say that, okay, so we know that the DP values are necessarily in increasing order. So the DP values might be something like, so the first DP value for 0 is 0, because we start out, or actually at the first loop paddle, that's the one, is 0, because we start out with needing 0 jumps, right? So that we have 0, and then, looks like this is our sample input. So the thing is, if someone has a question in the middle and I don't answer it, then they're just gonna get lost. So I kind of want to take questions in the middle. Okay. The next one is 0, so the answer is infinity. It's not possible. And the next one is 1. You can get that in one jump. This is the input, and this is the D. Okay, we can get to this next one in 1, and this is infinity. And then this is 2. Okay, so this is the input array, and this is the DP array down here. So if you ignore all the infinities, right? So say that you ignore all the infinities, and just look at the numbers. 0, 1, 2, 2. You notice that the DP array is necessarily in increasing order. And what this means is that when we use this formula here, we only care about the first j that is not equal to infinity, which means the first j such that dpj so the input j equals 1, basically. So to do this, one way is to use 2 pointers, as someone had earlier suggested. Another way is to use a queue. So if in the queue, first equals rightmost. Okay. That's not exactly what I was going for, but it's close-ish. It might also be right. This is a different one than what I'm doing. So if you have a queue, right? It's all locations. So we input into this queue all of the locations that have a 1. Right, so we'll push, so then locations equal 0 has a 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay. So we push these into the queue, right? And then when we're trying to find your DP array, what we can do is I'm trying to find DPI. You can say while lock dot first. Sorry about that. I'm not quite sure what happened, but just disconnected. Okay, what was the last thing I typed before the screen went offline? Just so that I know where I was. Like, alright, cool. I'm just gonna start again from here. Okay, so to find DPI, right? We have this blocker right here. Locations. We're gonna say, basically, our only option is to take, we want to take the leftmost element in locations such that it's within D. We say while DP or while locked off front. Alright, are you back online? Yes? Hope so. No? Alright. Put back online. So then DPI equals DP locked off front plus 1. Let's see. I don't have a name for this. I guess it is a convex optimization. Can I start again? Which part specifically? Which part should I start again? I mean, is it Vatzel? Sharma, which part should I start again? Okay, Q. Okay, I'll just re-say it. So basically, we want the smallest, we want the farthest location to the left, such that it's within the distance of D from location I. So we try lock.front, right? Lock.front is the first element in lock. It's the leftmost element, that's a 1. And now we say if it's less than I minus D. This means if it's too far to the left. If it's too far to the left, then we remove it. And the thing is, we can permanently remove it because when we increase I, it'll still be too far to the left. Q.front returns the first element in the queue. So a queue works something like, I do Q.push0, and the queue's like this. Then I add 3, then I add 5. Then I remove the first element, it goes like that. So front is basically the first element. Okay. Are there any questions? Oh yeah, and then once we removed all the locations that are too far to the left, we say dpi equals dp lock.front plus 1, which means the furthest element to the left that's still within D units, and then you just add 1 because we take one more jump. Okay, so it will never be empty because your current location is a 1. Right, you're only doing this if input I equals 1. So the queue will never be empty. But that's a good point. Alright. Are there any questions about this algorithm before I start actually coding it? No question? Oh. Yes, that is correct. So once you remove an element, it'll always be too far to the left. Okay, cool. Now, just one more technicality is if the frog cannot reach home, print -1. Okay, so one more thing that this thing can be binary search on DP array too. Yes, you can binary search on DP array. It'll just add an extra log factor. So currently this algorithm is O of n. If you binary search, it's n log n. So it works, it's just sort of slower. Okay, so if it's not possible, so the thing to notice is that that is a good idea, I guess. Alright, so the thing to notice if it's not possible is that if one lily pad is not reachable, then the last lily pad is definitely not reachable. So if one lily pad is not reachable, all the lily pads to the right of it are also not reachable. So let's just say that it's not possible to reach this because D equals 1 or something, right? If it's not possible to reach this, that means that nothing within D units, say D is 2, to the left are reachable. So we cannot reach anything D units to the left of the current lily pad. This means that anything to the right of it also will not have a lily pad. It may have a lily pad D units to the left, but nothing that is reachable. Yes, there is audio. Can you guys not hear me? Okay. Just making sure. Okay, good thing the audio is clear. Oh yeah, special thanks to Michael because he helped me test this out a few days ago and make sure that the audio is working and everything. Originally it was really bad, but he helped me clear it up, so thanks, Michael. Alright, so back to this, right? So yeah, if it's not possible to reach the beginning to one lily pad, it is not possible to reach from the beginning to any lily pads to the right. Okay, any questions about that? No? Alright, cool. So what this means is that so let's just say that there are no lily pads within D units, right? Then location.front will equal I because because I is necessarily a 1 and I is not too far to the left, for sure. Let's just say we initialize dp, all elements of dp to infinity. Okay, so then let's just say that lock.front is I, right? So this means that dp of lock.front equals infinity, because we've not set it. So we just say dp of I equals infinity plus 1. And it'll still stay as infinity, which means that dp of n will be greater than infinity. And that is perfectly okay. So if we know that the maximum the answer can be is n, because you're only going to jump a maximum of n times. So if dp of n is greater than infinity, then we know the answer is -1. Okay. Are there any questions about the algorithm before I start to code this? Actually, do I need to code this? Like, can we just, if you think I should code this, say something for me I shouldn't code this, also let me know. The things is simple enough that I don't need to code it. Okay, yeah, that's true. This is already pretty much the whole entire code. Okay, just to go over the runtime. Just to go over the runtime a little bit. So O of n to put all the elements in a queue, and then you loop through all I, and if input I equals 1, basically you loop through all I, and you only remove each element from the queue one time. So it's O of 1. Yeah, I suppose I'll just post the code in the group later. If you look at my submission, I coded the first version, which is O of n times d. And you just add a queue to this, and it'll work. I guess there's a lot of defines and stuff, but other than that, also we don't have that much time, so I'm just gonna skip the code and add it to the group later. Okay, so let's look at the second problem. This problem, I'm gonna like explain the problem statement a little more, just because it's such a confusing problem statement. Okay, basically, Bob wants to put a table in his room, right? And his room is n by n meters. So the each square of his room is either a 0 or a 1. 0 is free, 1 is occupied. So you want to find a rectangle such that its sides are parallel to office walls. Basically like something like that or like that. You get the idea. Just like a rectangle such that everything in the rectangle is a 0. And from all those rectangles, you want to find the one with the max perimeter. Okay. Are there any questions about the problem statement? Just because it was a very tricky problem statement. Alright, cool. So let's just get into the solution. So first of all, the brute force solution. Yes, the rectangles have to all be 0. the brute force solution would be to try all possible. All also rectangles, right? So that means like n squared starting points, or I guess it's n times n starting points, n times n ending points, and n times n to check a possible rectangle. The total runtime of this equals O of nm cubed. Okay, I'm not going to go over the brute force solution. So let's think about the DP solution. The last and then be saved using a table to sort of exactly. This is what we're going to do to speed it up a little bit. So the rectangles can contain the rectangles may not contain one. So in the first sample, the answer is if you look at these three on top, you put one on the left, three on the top, one on the right, three on the bottom. So that's 1, 2, 3, 4, 5, 6, 7, 8. And that's how the answer is 8. Okay. So let's try to figure out let's try to figure out. So someone said this up there. Last item can be saved using a table to store the sum. Repeating what specifically? I mean, you can always just go back in the stream right now to review it. Okay, so let's just say we're trying to still do all starting points, all ending points, right? The runtime is n times m cubed because we're multiplying this by this by this. I'll discuss the Python indentation problem last. So in order to reduce the runtime from O of n times m cubed, we have to reduce the runtime of one of these n times n, right? So let's just say that we want to reduce the runtime of, we can try all of them. So let's first try this last one here to check a possible rectangle. Yes, we can solve this with prefix sums, and that is exactly what we're going to use. So let's just say we want to check a possible runtime. Sorry, check a possible rectangle. So let's say we have dp of x1, or let's do row and column. Row 1, column 1, row 2, column 2. What should this equal? What is a good idea for this to equal? Given that we need to know if the rectangle is possible, what's a good thing for the dp to equal? No, what? Boolean. Yes. Boolean of what? How do we decide if this is true or false? Yes. Whether it's a possible rectangle is true. Okay. Here's how we, yes. Is that rectangle only of zeros? That is correct. So here's how we come up with this. We're trying to come up with a dp that checks if it's we need to reduce this of n times n that checks if it's a possible rectangle, right? So bool of dp r1, c1, r2, c2 is whether it's a possible rectangle, and that makes sense because that's exactly what we're trying to do. If we're trying to check if it's a possible rectangle, that's what the dp should equal. Just like in the previous problem, we're trying to find the minimum number of jumps, so the dp equals the minimum number of jumps. And that's normally how you come up with what the dp equals. Okay, so what information do we need to figure out if dp r1, c1, r2, c2 is a possible rectangle? Like what other dps are the input grid? What do we need to know? So yes, we need to check out that square if the sum is 0, but we're trying to do this without looking over all the elements, and we're trying to use previous DP elements to do this. Okay, DP. So this is partially there, yes. This is I think this got it, but it has the little overkill, but you're still missing something. There is a thing called 2D prefix sums, and this is exactly 2D prefix sums. Yes, this is, oh wait. Alright, let me draw a picture, and okay. Yeah, so you're exactly correct. It's not necessary to check this, since the first two already check this. So, let's say we have a grid here, right? No, not your bad, not your bad. So, you're allowed to, it's better to try and get it wrong than to not try at all. So don't, apologize for that. Okay, so you have R1 here, R2 here, C1, C2. Okay, so we're trying to figure out if this whole thing has only zeros, right? So far, we've gone with what? So far we have dp r minus 1 c2 to r2, sorry, r2 minus 1 c2, which is this range here. So we have checked if all of these is zeros, right? We've also checked if all of these are zeros. We took the end of these two. So in order to check if the whole thing is zeros, what else do we need to take? Exactly. The current self, if R2, C2 is 0. So and input of R2, C2 equals, I think this has to go in brackets. That's fine. So yeah, if we were using 2D prefix sums, we would have to subtract out this region here because we took it twice. But we're not taking the sum, so we don't need to do that. So that'd be exclusion when you subtract out that region there. Okay. So now we have the formula to test if the current cell is a possible rectangle. So now this is 1. Oh, we want to check the current rectangle. Cool. So that's great. Now the total runtime is O of nm squared, right? And we got a lot faster runtime. This was the intended solution to this problem. O of n times n cubed also ended up passing, but this was the intended solution. Okay, it turns out that yes, there is a faster solution. We can do this in O of nm times n. Let me look at the lag again, if it appears faster. So my lag's about 2 seconds now, or 2.5 seconds. Okay, so turns out we can do this faster. Because we do not need to look for every starting point. For every starting point, so we're not doing the O of n times n that's not DP solution. We're doing the, put the runtime here. O of n times n times n solution. Which is somewhat DP. Okay, so basically, yeah, that does not look like DP. Okay. Basically, what we can do is, we can just check every starting point. We don't have to check every single ending point. We can check a range of ending points at the same time. So, okay. So let's just say that what we'll do is, uh, let's just say that we're checking as this as the top left corner, right? Or it doesn't really matter, anyone. So what we do is we check for every element, we store the rightmost element such that the whole thing is consecutive zeros. Let's say that this is 0, 0, 0, 1. I'm just going to put these elements here that matter. Okay, ignore the rest of the elements. So for every element, we'll store all the elements foremost to the right that are 0. So this element will store that this is the farthest range to the right of zeros. This element. And again, we're just storing a number. So for here, I guess I'll put the number on the left because I guess there's more space. So here this is 0, 1, 2, 3, 4, 5, right? So for this element, we'll store that the farthest right we can go is 0. Farthest right we can go is 2 for all days, right? And the farthest right we can go here is 1. The farthest right we can go here is 0. And here is 2. And here is 0. Okay, we got all the farthest rights that we can go. Now, I will ignore the O of nm solution because that is not a DP solution. So this is the DP value that we're storing, which is the farthest right we can go. Now, the rest of the solution gets a little bit more tricky. So the thing to realize is, let's just say that we decide that this is the starting point here, right? And let's just say that we decide that the number of rows, we're going to only take one row. Then the one with the maximum perimeter will take as many columns as possible. So we'll go up to column 2, right? So we'll just take this whole entire thing here. And we'll check the perimeter. Okay, so far so good? And then we'll decide, okay, if this is going to be the leftmost, we tried with 1 row, now we'll try with 2 rows. And so the farthest right we can go is the min of the 2 here and the 1 here, which is 1. So this rectangle looks something like this. Okay, so then we got another rectangle, and we can check the perimeter perimeter equals 2 times length, or 2 times rows, plus 2 times columns. Okay. That was a terrible thing, but I couldn't undo it from there, so. Okay, so then we decide we want to take 3 rows. We take the minimum of 2, 1, and 1. 2, 1, 1, right? And that's a 1. So that makes this rectangle here, and we check the perimeter again. Then we decide we want to take 4 rows. Take the minimum of 2, 1, 1, and 0, which is 0. And we go to another rectangle here. I'm going to take the perimeter of that too. If we decide to take 5 rows, the minimum of 2, 0, 1, 1, and 2 is 0. So this is our rectangle, and so on and so forth, until we get down to all the rows. Sketch.io. I tried that. It was kind of weird and it. Splix.io. Okay, let me try Splix.io. Okay, that's a game, it looks like. Yeah, that is a game. The value would be -1. Okay, so if the current value, yeah, if there's a 0, and that's how you keep doing this. If there's a 1, then the current value would be -1, and you just stop. Okay, so any questions about this algorithm? So the runtime is n times n times m. Because we check every single starting point. We do this for every single starting point, right? And then, yes. Yes, you do calculate this. That's the DP part. Okay. If you don't check every single ending point, you check every single ending row, which makes the number of ending points n. And this runtime goes down to n times n times m. Okay, should I code this or no? No. Alright. Oh, so yes. Alright, I'm just gonna. So which of the algorithms should I code? The brute force, or the n squared m squared, or the n times m? Which of the algorithms should I code? Okay, I'm not coding the n times m, but I'll code the n times m times n. Okay, so I'll try to do this really quick because we're sort of running out of time. I think n can go up to 25. So sin is slow, but then if you use sin.tie0, it's faster, but you don't really need that for this problem. Scanf is just annoying to use. Okay, far is gonna be, yeah, that's what I normally use, but that's fine. Far is gonna be how far, like the furthest to the right that we can go. Okay, so to find far, we're gonna start j at m-1 and we're gonna go backwards. Why is my input wrong? Okay, thanks. It's also you code how far it can possibly be. Now I'm just gonna go for every possible starting place. Distance basically is how far we can go. That's a good point. I don't think we need this part here. Okay, oh yeah, and I do need to set an infinity. Out is the answer. So the row would be, actually I do think I need this. So we're not going to continue going down if the current thing is a 0. Sorry, is a 1. Okay, 29. Okay, I'm going to try this, see if it works. I'm in the wrong spot. So it doesn't matter if I use \n or endl if it's just one print value. Okay, all these so far look good. I'm gonna try submitting. Okay, and it worked. Alright, so any questions about this code before I move on to the next problem? It's a fairly simple lesson, 40-line code. Oh, the +2 is so the +2 is, let's just say I'm looking at this thing right here, right? The number of rows is 1 and the number of rows is from 0 to 0, which if you just do 0 minus 0, it'll be 0, but you want it to be 1, so you add 1. And the number of columns is 0 to 2. If you do 2 minus 0, you get 2, but you want it to be 3 because it's 3 columns, so you add 1. Cn does get char by char because grid is char. Can I explain the far on the first sample? Okay, sure. So far for this would be 2 because it's a 0 and it's the last element. Far for this would be 2 because it can reach index 2. Far for here would also be 2 because it can reach all the way to the end. Far for here would be 2. Far for here would be 0. Because it's at index 1, but it'll be the previous index, which is 0, because it cannot reach that far. Far for this would be 0 also, because it equals far for this equals 0. And then far for here would all be 2, because they can all reach to 2. The reason I loop backwards while doing this is because I use j plus 1. Okay, any other questions? No questions? Cool. Alright, so we took about 30 minutes on each of the first two problems. I do have a video on taming the herd already, so is it alright if we skip taming the herd and we just move on to Python indentation? Or does anyone really want me to? Yeah. Okay. Alright, cool. I don't think I'm gonna put the postal link, but here, I can put the link of my code in the description. Okay. So this should probably be in the description. Hopefully soon. So we're not on that problem. Okay, cool. Well, let's do Python indentation. So Python codes are defined by indentation. So you only have two types of statements. You have statements, simple statements, and you have for statements, which are basically like loops. So the thing about Python is every time you have a loop or for statements, the next line must be indented one more, whether it's a for statement or a simple statement. And the loop body cannot be empty, so the next line must be indented one more. You're given statements without indentations. Find the number of ways which the statements can be indented to form a valid Python program. Okay, cool. Oh, and modulo 10 to the 9 plus 7. Alright, so let's first think about what the DP would be. So we need DP something, right? But I think the easiest thing is, what does it equal? What should the DP statement equal? I don't think people in North Korea get access to the internet. I don't think that's the thing. Okay, so our output is the number, like what we're trying to print is the number of ways that given sequences can be indented, modulo 10 to the 9 plus 7, right? So what should our dp equal? Okay, yeah. So what is it? Votsal, I think, and Michael are saying is dp position and level of indentation is correct. What should it equal? Yes, exactly. Equals how many ways how many ways are possible? And of course mod the modulo thing, but that's fine. Alright, so we have our dp. This is perfect. Okay, so now if we know all the dp, we know all the dp from 0 to I minus 1 for j is 0 to max j. Okay, how can we use this to find dp ij? How did I decide the states? Okay, so the first thing you decide is what is it equal? And this normally is exactly what the answer is. How many ways to make this possible? Which is exactly what the answer is. And then from there you think, okay, to decide if our current position and level of indentation, how do I do that? Or you think, how do I do it? And then you think, okay, you need the current level of indentation because that matters to see if you can indent less or not. And you need the current index. Index is almost always a DP state. So that's how you figure out that you need the index. That's always DP state. Level of indentation is something else you need to figure out if you can remove it. Okay, so if you know, how do you figure out dp I minus j given that you know everything from dp I equals 0 to I minus 1 and j goes from 0 to max j? Okay, has anyone, I guess that's what the tricky part is. No one has yet figured this out. Yes, this is exactly right. Depends on the previous character. So, I think, I'm not sure exactly what Michael's is saying, what you mean by compound, but that sounds about right. So if the input of I minus 1 is a for loop, that means that our current indentation has to be one more than the previous indentation. Okay, so, okay, that makes sense. For statement is not compound. I'm not sure what the cubic solution is, to be honest. Alright, so dp ij equals dp I minus 1 j minus 1. Yeah, that's correct. The current indentation has to be one more than the previous one. So if the current is dp ij, the previous is of course with the previous index, j minus 1, because the previous is one less indent than the current indent. Can you not indent 2? What do you mean by that? I don't know what you mean by that. Sorry. Okay, so I'm getting the simple statement. So if the previous one is a compound statement, then this is exactly what this is. Okay, you cannot indent the current statement extra. Like if the previous one is a for loop, the current one must be one more indented than the previous statement. Exactly one more. Shouldn't be one more state that says what was the previous letter. So you don't need a state for that. You don't need a state for this because it doesn't change, right? The previous letter, you can just use an if statement to check. Okay. What about simple? Okay, else. Which means that the current statement is a simple statement. The previous statement, the simple statement. Which means that the current statement cannot be one more indented, and the current statement indent is less than the previous statement indent. What this means is that, oh, I think I understand what Filippo meant by the cubic solution. Yeah, so I'll do the cubic solution first right now, and then I'll show how to get it to the squared solution. Okay, so dp ij equals to the sum of all dp I minus 1 j to max j. Okay. Yeah, this was also the first solution that I came up with, and then I just sped it up. Alright, cool. So, are there any questions about this dp state so far? Okay, now let's talk about the runtime. The number of states. So, max j, the max indent, is basically n, right? I'll put that up here. So, the runtime is the states times transitions. I don't understand the previous character is s. Okay, so if the previous character is s, let's look at this in terms of this, right? Say I have f, and then I indent f, then I have s, right? Now, if the previous character is s, then I can put my next statement here. F or s doesn't matter. I can put it here. I can put it here. I can put it here at this indentation, or I could put it here at this indentation, right? I could put it at any indentation that's less. But if the previous statement is s, I cannot put it here. Oh, the base case? The base case is if you start at index 0 with 0 indents, that's one way to do that possible. Okay, so I just explained this line again, right, with the whole indent thing like that. You can just rewatch it, or if you have a specific question, you can ask that. Okay, states time transitions. So the runtime equals the states is n squared times the transitions is O of n. There are n transitions here, because you can look at n different elements. Okay, now, if you code this, unfortunately, it will get TLE. So there are two ways to do this. I think the easiest way to explain this is to say that we can do a 1D prefix sum where we let we have prefix of ij, which equals the sum of dp I j to max j. And then you have pre-ij equals dp ij plus pre-ij to figure out pre-ij. Another option is you don't need to here, okay, so yj plus 1. Okay, so you're trying to, this is your of the line. You're trying to find the sum of all these elements here, right? So pre-ij, oh yeah, I guess it's the suffix sum, not a prefix sum. So let's just say that like pre-ij equals this, right? Now, if we're trying to find the pre-ij of this whole box here, this equals to the red box plus this green square here, which means that the purple box, pre-ij, equals to the green box, dpij, plus the red box, pre-ij plus 1. Thanks for subscribing. Okay, so that's what the suffix sum is. Okay. Are there any questions about the suffix sum? Because I know it's kind of confusing. If not, okay, cool. So then we can say this equals to suffix of ij. Oh, I'll code this later. I'll definitely code this later. Basically, you just loop backwards for all I. Oh, okay. So yeah, we're looking at deeper indentation levels because let's just say that we're trying to solve it for this point here, right? This point can come from any of these indentation levels here, or actually any of these indentation levels here. Actually, no, it is bottom up. So this point can come from any of these indentation levels here. That's the difference between, top down you would look at previous less indentation, here you're looking at greater. Okay, so this is the whole entire DP. Does anyone have any questions about the idea here before I start coding it? Okay, cool. So a random one of these. Actually I don't want that. We'll just make a new one. Okay. Yes, suffix for summation. Cool. So the DP solution is O of n squared. Is that what they said the mod was? 10 to 9 plus 7. Cool. So oh yeah, sorry. Alright, cool. Okay, so now we have our DP, which is 5,000. And the max indent is 5001. Actually, yeah, by 5000. We have sum 5000 by 5000. Okay. So everything's initialized to 0 initially, which is great. Now our base case is DP. If we start at the first element and we have taken, and the indent is currently 0, there's one way to do that. Okay. There's no other ways for the index to be 0. So we're going to start at 1 when we look at our index. Also, especially since we're referring input of I minus 1. I'll just copy this directly. Okay, this is so far so good, right? And then okay, now we just need to write the program that'll create the suffix. Oh, actually, we need suffix I minus 1j because we need the sum of the previous DP values. Okay, let's create the suffix array for I minus 1. So max j equals n minus 1. Suffix I minus 1 j equals suffix I minus 1 j plus 1 plus dp I minus 1j. Actually, suffix I minus 1 n minus 1 equals dp I minus 1 n minus 1. And this should start at n minus 2. There is a nested loop. There's loops here and a nested loop is here. So it's the runtime is n squared. Okay, our answer should be, we can end at any indent, right? Oh yeah, also suffix has to be done modulo the mod. Just because there's a modulo of 10 to 9 plus 7. Why is what specifically? You put the mod if you're adding numbers. So here we're adding these two numbers, so you're putting a mod. Here we're just saying they're equal. So if dp I minus 1 j minus 1 is good, and dp ij will be good. And suffix is already good because we took the mod when we set suffix. And this is just one value, so we don't need the mod. Okay. So you don't have to add one because you're not adding any other cases. You're just changing the current cases from the previous index. Yeah, this. Wait, no. 5,000 squared will not. 5,000 squared will not get COTLE. You could do this. You don't need to. 5,000 squared is what? Yeah, this should be fine. 25 million under 500 million. This is bottom up. J is out of scope for 24 and 29. That's not true. Oh wait, yeah, you're right. It is. Good point. That is a good point. Okay, also we're using j minus 1 here, and j starts at 0. So this is if j is not equal to 0. If j is equal to 0, then this is not possible. It's actually possible for this to happen, but it's not possible sequence of indents. So it's just equals 0, which is already initialized to 0, so that's fine. I know I'm bad at math. What am I gonna do? It's fine. Okay, let's try out. Oh yeah, and then I have to write the answer. So it says the answer is 1. Oh, and then it's supposed to be 1. Okay, that works. Freaking out there for a second. 2. Okay, cool. So this is chapter 11. I'm gonna try submitting. You're right. Out calculation does require mod. That's a good point. That may be the answer, or for the bug, or maybe something else. Let me see. Yeah, out calculation does require mod. Okay, let's submit this again. Alright, it works. Okay, so we got through those 2 problems. Are there any questions before we end the stream? None? Alright. Suffix is the sum of all dpi from suffix ij is the sum from dpi to j up to max n. Next week's problems will come out hopefully tomorrow. I have the problems written down. I just need to send them out and come up with a feedback form. If you have any feedback right now, that would also be great. You know, I like to help others, especially since when I tried to code it was pretty hard. So that's, yeah. I'm glad you appreciate it. With this problem, you have to use all the. So you don't use the last character in the input. It's kind of weird. Yeah, the last character, you don't use it. Maybe spend less time on problems. If I spend less time on problems, what would I spend time on? Okay, so challenge questions. What difficulty of problems do you think is a good difficulty for challenge questions? But I can definitely add them, but I just need to know what difficulty. I could take questions off of course 3. Less time on some of the easier problems. Okay. Yeah, I could definitely do that. Questions. I don't. I want to allow questions during the stream, but if it's distracting, maybe I'll try something else. Okay, I could definitely do that. I already have the code, so yeah. Okay. Next week I'll see if I can come up with 2 or more. Uh, what is the CF stream? So now you know how to write DP with for loops because we went over. Okay, next time I will try to go a lot faster. So, uh, yeah, what specifically do you mean by faster? Like, which parts were too slow? Okay, I'll send out a feedback form about like speed and stuff and what I can do next time. Yeah, okay, so I guess that's the end of this stream. I will see everyone next week, and I spent too much time answering the chat. Okay, I guess if I close the chat and I can just look at that once in a while and spend like chunks of time. Oh, you think I? Okay, I'll send out a form. I'll put in like speed and how much time I spent answering the chat. And if you have anything else I should put on the stream, let me know. Okay. Also, if you could subscribe, that would be great. Yeah. Oh, if you're doing debugging next week, um, Filippo is gonna be helping me out with debugging. So that's why I was able to take so many people. And so just thanks to him. If you're doing debugging, send a thanks to him too. And yeah, okay. I will see everyone next week. Bye.